So this is video 6 of our introduction to R. Previously, we talked about the logistics, why we want to code in R, R for data management, running basic RStudio commands, installing Swirl, and this video will kind of bring us more into the details of actually writing R code. So key things to note when we're using declaring variables in R is that if we have a variable x and we want to assign it a bigger value, we can use this pointer to assign it a value of 1.5. The spaces here before and after do not matter. We can have one space, many spaces, no spaces. It doesn't make a difference. What we do need to do is have this less than symbol and this dash together without a space. And that will assign x to the value of 1.5. We could also use a single equal sign as well and assign x a value in that manner as well, in the same way. And that will work just as well as using the pointer. However, the pointer is more conventional, arguably. And we could do that for x and assign a value also in the same way for y. And y equals 2.6 actually does the same thing. The standard operators we're used to also work in a similar way. The nuances is that a star b, asterisk b, it means a to the power of b, and a percent b is a modulus b, a mod b. So that means getting the remainder. And that means that when you're writing code in OR, you can do complex queries like the one shown down below, and OR will be able to work that out for you. So OR works very well as a simple calculator. So we can do more advanced things as oh yeah, I said that. So we can do more advanced things with R. So we can create vectors. Vectors can create none or many entries. So a vector could correspond to a single row or column in a spreadsheet. So we can create a vector most easily using the C function in R, which stands for concatenate. So to create an empty vector, we write this code here. X is assigned the value of C with nothing in it. What we want to do is add in numbers. So in this case, we'll add 1, 2, 4, 8. And you note here that there happens to be no spaces, but that's just to fit it onto the PowerPoint here. We could have one or many spaces here, and OR will recognize that these are numbers. So this creates a vector with 4 different entries, 1, 2, 3, 4. So 1 is the first element, 2 is the second element, 4 is the third element, and 8 is the 4 is the third element, and 8 is the fourth element. There are different functions for these operators. Obviously, when we're looking at DNA sequence, where we got the amino acid code, reading in triplets and using mod 3 can actually be quite useful for reading through DNA bases. So you can find that these things do actually become handy at times. One thing to note, if we're manipulating vectors, is that we can add or subtract or multiply or divide from x and y if they're vectors of a particular length containing multiple entries. If x and y have the same number of entries, normal options apply. So that means if we look at these vectors down here, the first element, if we multiply x by y, the first element is multiplied by the first in x is multiplied by the first element to y. The same for the second element x and the second element to y, and the third element x and the third element of y. However, if they have different numbers of entries, like the one shown down here, no operations will apply for the vector with the fewest entries. So this won't work for the fourth element in y. So if we assign z as the product of x and y, OR will panic, but it will try to give you an answer. So just for illustration, if we have vectors here with x and y, which have the same number of elements, we can multiply them together to form a new vector v in that way. And v will give us the products of 55, 132, 231, and 352, corresponding to 1 by 55, 2 by 66, that gives us 132, 3 by 77 is 231, 4 by 88 is 352. If we do x divided by y, again, we'll get 4 elements, as you would expect. If we have this particular example, where we have 1 divided by v, again, that will also give us an output. You'll note that in the previous instance, v was small values. If we do v plus x, again, that will give us 4 values shown here. If we do v plus x by y, it will multiply x by y first, and then add v onto it. So it gets 55 and adds the small amount of v onto it, getting 55.02. We can also concatenate existing vectors together just as if they were numbers, and in many ways, or treats x and y just as if they are numbers. And we can assign them as v like this. And that will create a vector with 8 elements instead of 2 with 4. If you create many variables, and you can see that I overuse x all the time, which is not a good thing to do, you can list all the variables that you have present using the ls command, which is a bit like the command that many of you will have come across in Unix. If you wish to remove them, you can use this command, or list is equal to ls, but I recommend not doing that and just being careful with how you name things. A vector can also be a condition as well as a number, and we can subselect values within a vector using these conditions. So for example, if we want the positive elements of x here, so those greater than 0, we can say subselect x greater than 0 inside these square brackets from x, and that will give us the answer of 1, 8, and 12, a 3-element vector. If we said x greater than 5, that would give us 2 elements, 8 and 12 at the end. If we had said x greater than 10, we could just get 1 element of 12. And if we said x greater than 13, we'd get nothing. Vectors can also be sets of strings. So we could have a vector containing purple and green and blue as strings like that. And these are not numeric, they're characters. And note that the quote type here is or ones that should work with the code that they're writing. You should avoid having a vector consisting of numbers and strings, because OR will treat that as entirely as just strings. It will not recognize that it is a number. So we can have multiple conditions in this way. So if we have the same vector of 1, 0, 8, 12, and 0, we can use the ampersand to indicate that we want both conditions to be true. So R will evaluate this first part. So we want the elements that are greater than 0 in x, which are 1, 8, and 12, and also the ones that are even. So x mod 2 with a remainder of 0 means that we only want elements that are even, which are going to be 0, 8, 12, and 0 here. So that means that we get the result of 8 and 12. We can also have more advanced ways of manipulating vectors, and this is given here. So the first part of this command, x going from 1 to 3, selects the first 3 elements of x. So that's 1, 0, and 8. And then within that, we select from those first 3 elements the ones that are positive. So that gives us 1 and 8 at the end. So that's a more advanced way of sub-selecting elements from x. So please note that we have the double equal sign here for the modulus function, because that compares data, whereas a single equal signs assigns. More function operators that might be useful are the ones you know already, greater than or equal to, less than equal to. We can also use compound ones to have ones that are less than or equal to, and greater than or equal to, not equal to. So the exclamation mark means not. And we know double equals is a comparison. So we can combine these using these and pipe symbols. So and means we want both criteria to be true, and for the pipe we want either to be true. So if we had a pipe here instead of the and, we could have x greater than 0, which corresponds to 1, 8, and 12, or x mod 2 equals 0, which would have given us 0, 12, 8, and 0. So in that case, if we had a pipe symbol there in the middle, we would have got all 5 elements of that vector back. So that kind of concludes our video into how to do manipulate vectors, variables, and operators with R.